In this video, we're going to do an example that's similar to questions 6, 7, and 8, and then we'll go ahead and do one of those and enter it into the computer. Now, really, the only difference between question 6, 7, and 8 from 1 through 5 is that we now have variables there. We're still using the product property to pull out as much as we can. In example 6, since it's a cube root, we're looking for perfect powers of 3. In example 7, also a cube root, but then in example 8, it's a fifth root, so you're looking for perfect powers of 5. Let's do a similar problem on a separate piece of paper. So here we have it. We're asked to simplify the square root of 405 times x to the 6th times y cubed. Now what's nice about the product property, because this is all multiplication going on here, I'm going to even emphasize that, we can think just about the square root of 405 on its own, then think just about the square root of x to the 6th on its own, then just think about the square root of y cubed on its own, and multiply those three together. With a lot of practice, you'll be doing this all simultaneously, but I think right now it's nice to just think about each piece separately. So let's consider square root of 405. Now, perfect squares, we should use in different colors now. How about we go to just gray? Perfect squares we listed right here. I'm hopeful, and there's more, right? I'm hopeful to get the largest perfect square that'll divide in evenly to 405. But even just finding one perfect square that divides in evenly is helpful, and I want to illustrate that here. Notice 9 is going to divide in evenly to 405. One nice trick about the 9s is if you add those digits up together, 4 plus 0 plus 5, you get a 9. So I know 9 is going to divide in evenly there. So let's just do that on a calculator. 405 divided by 9 is 45. And using my product property, that's the square root of 9 times the square root of 45, and the square root of 9 is 3. But we're not done, because 45 has another 9 in it, another perfect square factor. 45 is 9 times 5. So I could use my product property again. 3 times the square root of 9, which is 3, times a 5. 3 times 3 is 9, times the square root of 5 is 9 root 5. Now you could have gotten there faster. This is perfectly all fine. But notice that if I found that 81 divided in evenly to 405, .405 is 81 times 5. Look how much quicker we got there. Square root of 81 times the square root of 5. The square root of 81 is 9. The square root of 5 is just the square root of 5. So that's the benefit. It's kind of similar to when you're simplifying fractions. Like, I'm looking for the largest perfect square factor here. Then I don't have any more reducing. But notice that I found just one perfect square here, and then I had to find another one again. 45 is a 9 times 5. That's fine. All right, so we've done one piece here. we've dealt with the square root of 405. Now let's go ahead and deal with the square root of x to the 6th. All right. So maybe I'm going to write this, because I can take roots across products, I'm going to write this all with perfect powers of 2. X to the 6th, and maybe we even like this. X to the 6th is x times itself 6 times. 1, 2, 3, 4, 5, 6. There's some perfect squares here. X times x is x squared. X times x is x squared, and x times x is x squared. I can now use my product property. The square root of x squared times the square root of x squared times the square root of x squared. In this, in our book, it's telling us that all the variables here are positive, so I don't need to deal with absolute value. The square root of x squared is just x. Square root of x squared is just x. Square root of x squared is just x. X times itself 3 times is x cubed. All right, and this is all great. This is all good work, but you could have done it faster if you noticed that x to the 6th is x cubed all squared. And so now I'm square rooting a perfect square. My answer is just sitting right there. Right? So similarly up here, like this was a little bit faster, but this is perfectly good. All right, and so now we've got 3 of the pieces. Let's get the last piece in here. How about blue? So let's simplify the square root of y cubed. Let's go to the next page. So y cubed is y squared times y. Product property. This is the square root of y squared times the square root of y. Square root of y squared is y. Square root of y is just square root of y. You don't have to write the little dot for the multiplication if you don't want to. All right, so now we're ready to put the 3 pieces together. We have, I just copied what we had from above. The square root of products are the products of the square roots. We simplified the square root of 405. Yellow is yellow, right? It's 9 times the square root of 5. We simplified the square root of x squared to be x cubed, right? Orange is orange. And we simplified the square root of y cubed to be y times the square root of y. All right. Now, order doesn't matter in multiplication. I'm just going to rewrite this all. Oops, I dropped the root. I'm just going to rewrite this all without any color. Right? And I think it's nice for us to lead with the number, then times x cubed, then times y. And that part's kind of superficial. But the square root of 5 times the square root of y, I'm going to now use that product property in reverse. The square root of 5 times the square root of y is the square root of 5 times y. Right? Just right here. And that's typically done. The things that can't be pulled out, that aren't perfect squares, are left underneath the radical. You would have gotten this, you can get this answer faster, but we took advantage here of compartmentalizing our thinking. When we're doing something new, sometimes it can be overwhelming. So I thought about the yellow, the orange, and the blue separately. But if you're thinking about it kind of all at once, you would have left that 5 underneath the radical, and you would have left that y underneath the radical. And I think this is just a little bit cleaner for us in our answer. This was one that I'm just making up, so that one we're not going to put in the computer. Let's do one similar, or do an exact one, in fact, and then enter it into the computer. I think I want to do 7 because of that negative in there. All right, so let's do problem 7 together. All right, so I'm going to use my product property. This is the cube root of minus 40 times the cube root of a to the 4th times the cube root of b to the 4th. And now go ahead and compartmentalize my thinking. I'm just going to work on the cube root of minus 40. I know that minus 8 times 5 is 40. And minus 8 is a perfect cube. All right? Minus 2 times minus 2 is positive 4, times minus 2 is negative 8. Negative 2 cubed is minus 8, so the cube root of minus 8 is minus 2, and the cube root of 5 is just the cube root of 5. All right, and now let's do the cube root of a to the 4th. I think we got space to do this here. A to the 4th has a perfect cube in it. It has a cubed. Right? A cubed times one more a would be a to the 4th. Using my product property, we have the cube root of a cubed times the cube root of a. The cube root of a cubed is just a times the cube root of a. Orange is orange. And the work that we did for orange is the exact same work that we're going to do for blue. The only difference is that we've got a b instead of an a. So let's go ahead and see that algebra one more time for the heck of it. The cube root of b to the 4th is the cube root of b cubed times b, because b cubed times b to the 1 is b to the 4th. Product property, cube root of b cubed is b times the cube root of b. All right, and we're done. We're going to put this all together. Right, I just copied the work that we had from up above, and we simplified yellow to be minus 2 times the cube root of 5. Orange is a times the cube root of A. Blue is B times the cube root of B. And one thing that's kind of nice, actually, is that the computer will accept this answer. I want to clean it up further, but let's go ahead and put this in. All right. Okay, so we got -2, and then for cube root of 5, you're welcome to go ahead and use this typing, but I'm going to just use my little yellow arrow. I'm grabbing this nth root. It defaults to cube root, which is great because I need a cube root, but if I needed a different root, I could just change that number. I want cube root of 5. Now I have to come outside of that root. If I go ahead and hit A, do you see how I'm underneath the cube root? So, but if I just move my cursor over, now I'm outside of that square root. So now I've got A all on its own, so multiplied by 1A, and then multiplied by the cube root of A. And again, now I want B cube root of B. If I write my B right there, see how it's under the cube root? I don't want that. Our answer, the way we wrote it all out in factored form, was B and then the cube root of B. Save, and that's exactly what we have written on our notes. Submit, and it's happy with that answer. Now I think we could make that answer look better, and so let's go ahead and do that and then enter in the answer and see that that is accepted as well. Right, so I'm just going to rewrite this without color. -2 times the cube root of 5 times A times the cube root of A times B times the cube root of B. I'm going to go ahead and lead with my numbers, -2, then times A times B, and then end with all my cube roots. And the reason for that is I can simplify this. Right, using my product property, the cube root of A times the cube root of, the cube root of 5 times the cube root of A times the cube root of B is just the cube root of 5 times A times B, and that looks a heck of a lot nicer. And you could put in your dots. I think at this point right here at the end, it's nice to, we don't need to emphasize that multiplication. So this is better, it's just cleaner, but this is, oh, this right here is okay too. I like that XYZ is accepting that answer. Okay, so let's put it into the computer and then that'll conclude this video. All right, so here was the answer that we had typed when everything was all factored. I'm going to go ahead and delete it. And now I want -2 times A times B times the cube root of 5AB. So I'm going to get that cube root coming here. The cube root is the default. And underneath that radical, underneath that root, I want a 5AB. Right, so make sure that it's all under it. If I do this, that's saying something different. All right, that's what we want. Oops. And ta-da! We did great. All right, so that concludes this video talking about problem 6, 7, and 8.